All right, good morning. This is the last lesson on systems of equations. Again, it has to do with linear equations only, or linear lines. And what is a system again? It's two equations, both lines, that's what they represent, because you don't see an x squared or a y squared or anything like that. And a system is two lines, and where the answer to the system is where they cross. Okay? And last lesson we found out that if they were parallel, they would either not cross at all or cross at infinite points, because they'd be right over top of one another. So those were two cases, and then the third case, or the most common case, is where they would cross only at one point. They would not be parallel, and they would cross only at one point. So what we're going to be doing is actually solving for what that point is, or what point will solve both of these equations at the same time. Okay, 2 times some number minus 4 times a different number is equal to 7. And if you take that same number times by 4 plus this same number, it should equal 5 as well. So there's only going to be one solution for this systems of equation. Again, you can kind of picture one's going to be some form of line and one's going to be some other form of line. Our solution is where those two lines cross, or what point, what x comma y point will solve both of these equations. Okay, so this, we use the word substitution, and it's a very important thing in math that you'll see down the road, and you'll need to know how to do this for lots of different math concepts down the road. And it has to do with linear lines. Okay, where they cross is our guess. So we're going to solve these without graphing the lines. Okay, we're going to find out what that intersection point without drawing it out. Okay, and this uses something called substitution. So usually what you always do when starting these equations is you write the first one as 1, the second one as equation 2. Okay. And then what you do is you choose either 1 or 2. You have to solve for a variable, either x or y. So it's very vague. You can choose and it'll get you to the same answer in the end. So when I see this, I see 2x, 4y, 4x, and a y. So I see the y does not have a coefficient in front. So that's probably going to be the easiest one to solve for, that y in the second equation. So what I'm going to do is I'm going to solve for y in the second equation. Okay, so I'm going to write y, or I'll just rewrite that equation, 4x plus y equals 5. And I'm going to solve for y, so I'm going to minus 4x to both sides of the equation. And I'm going to get y equals 5 minus 4x. Okay, so we just solved kind of for y. Okay, so now we have this y equation, 5 minus 4x. And then your next job is to plug, we say plug, this equation wherever you see y in the other equation. So we used 2 here, so we got to plug this here where we see y in the first equation, right there. And how you do plug into equation 1, and how you do that is you write equation 1 out, so 2x minus 4y equals 7. And you take this whole right side of your equation, 5 minus 4x, and you put it instead of the y. So y is this, so instead of y, we're going to write that. Okay, so now we have 2x minus 4. And instead of writing y, we're going to put brackets, and we'll put that 5 minus 4x, like so. And then we're going to finish this equation, 2x minus 4y, 2x minus 4y equals 7, equals 7. So now we have that. And then your goal here, if you notice, we got rid of the y, and all we see is x's. So that's what we wanted from this, plugging one equation into the other to get one variable only, because then you can solve for that variable. So the next step here is you have to distribute, if we remember how to do that, into that bracket. Okay, this will always be most likely a step in these types of solutions. So 2x We go negative 4 times 5 is negative 20. Negative 4 times negative 4x is plus 16x equals 7. So what would I do next here? If you notice I have like terms, I have two x terms here, so I can add those together. 2x plus 16x is 18x. I couldn't add the 20 because it does not have an x. So I have to write that negative 20, and then I write that 7. So that's a little more simple. Let's get x by itself because we want to solve for what x is. So we're going to add 20 to both sides. And we get 18x equals 27. And then last of all, we have to divide by 18 to solve for x. So we'll get 27 over 18. And one thing you notice with that is 9 goes into both 27 and 18. 9 goes into 27 3 times, 18 twice. So our x value that we get, I'm going to put a box around it so we remember. The x value where the two lines will cross has to be 3 over 2, or also known as 1.5. Okay, so that is my x value that solves both of these equations. Okay, so we know that. So what we have to do next is we have to take this x value and plug it into any of the equations that we see. Okay, and then we solve for y. So the easiest one to do is to plug into this one here, because we already solved for y. We just have to plug now this x back in for that variable and find out what y is going to be. Okay. Again, you could choose any equation and it would get you the same answer. So now we plug x equals 3 over 2 into equation 2. So equation 2 is that, but we simplified it as that. So I'm going to use that equation. It's 5 minus 4x. And instead of writing x, we're going to write 3 over 2. So y equals 5 minus 4 and 3 over 2. There you go. So now we just have to solve what y is going to be. And how we do this is usually, well, these two numbers are being multiplied. It's 4 over 1, and what you do with multiplication, it's top times top, bottom times bottom. So we'll go y equals 5, negative 4 times 3 is equal to negative 12, and 1 times 2 is equal to 2. So we get that. We know negative 12 over 2 is just negative 6. And then, so 5 minus 6 is going to be equal to negative 1. So now we have that, and that's our solution. So we know that the point that it's going to cross the two lines, or the point that's going to work for both of these equations, is going to be 3 over 2, comma, negative 1. So that's my solution for this system. Okay, those two equations, the only two numbers that will solve both of these equations will be 3 over 2 and negative 1 for the y. So that's how you use substitution to solve for a linear system. It's you can see it's quite complicated. It takes a lot of calculation in algebra, but you can solve a pretty complicated thing using just math. Okay. This next one is quite tricky. You have to use quite a bit of fractions to answer this one. I would say this one's one of the toughest type of questions that you would get. Okay. So here you label 1, 1, 1, 2. We notice that 2 is already solved for y, because we can solve for x or y, but this one's already solved for y, so we're going to use that right ahead. Okay, so we're going to plug 2 into 1, okay, because it's saying y is all this stuff. So now let's plug all this stuff in for that y. Okay, so we have 1, which is half x plus 2 over 3y equals negative 1. Instead of that y, we're going to write all this stuff. So it's going to be half x plus 2 over 3, and we're going to write 1 over 4x minus 5 over 3 equals negative 1. So you can see it already looks really complicated. First step, just like last one, we have to distribute into those two terms there. Okay, so I'm going to rewrite that 1 over 2x. And then with multiplication, you go top times top, bottom times bottom. So it's going to be 2 over 12. So it's going to be plus 2 over 12x. And then we go 2 times negative 5, gives us negative 10. And then 3 times 3 will give us 9. And this will equal negative 1 again. So now I got rid of the brackets, and it's a little more simple. My next step is I have to combine like terms, just like the last question. But I have a problem here. I have 2 x terms, but you cannot add something that has different denominators. So what do we do there to combine them? We have to make the same denominator. So we have to times this 2 by 6, but if we times the bottom by 6, we have to times the top by 6. So this will bring us to a 6 over 12x plus 2 over 12x minus 10 over 9 equals negative 1. Now I can combine both those x terms because the denominator is the same. When you have the denominator the same, all you do is you add the top numbers and you keep the bottom numbers the same. So we have now 8x over 12. And now we just copy everything else down. Negative 10 over 9 equal negative 1. And our goal is to solve for that x. So we got to add the 10 over 9 to the other side. There we go. So now we got to combine these two numbers here. But if you see, there's plussing and the denominators are not the same because this denominator is 1. So we have to make them the same. So we have to times this by 9 to make it the same, but that means we have to times that by 9 as well. So we get 8x over 12 equals negative 9 over 9 plus 10 over 9. And now we have to, now we can add those two terms. We just add the top numbers and keep the bottom one the same. So now we have 8x over 12 equals 1 over 9, because negative 9 plus 10 is 1. Alright, so now this next part, if you want to solve for x, if you remember how to do cross multiplication, you can do that. You kind of go 12 times 1 and 8 times 9, and you get 12 over 72. Okay, another way you can do it is we just have to get rid of that 12, so let's times both sides by 12, and we'll get 8x equals 12 over 9. And we got to get rid of that 8, so we have to divide by the 8, and this will bring us to an x is equal to 12 over 72. And I notice that that simplifies to 1 over 6. Okay, because 12 goes into 72. So our x value, square, for sure has to be 1 over 6. Okay. Now what I do is I take this x equals 1 over 6 and plug it into either of these equations and now solve for y. Okay. The easiest one is this one because it's already solved for y. So we're going to plug into 2. So I'll go up here. So we have y equals 1 over 4x minus 5 over 3 as our y value. We know our x value has to be 1 over 6. So I'm going to rewrite it, but instead of x, I'm going to write 1 over 6. Like so. And now what do? We have to multiply first. So top times top, bottom times bottom. And we'll get y equals 1 over 24 minus 5 over 3. And now we have to add those two together. Denominator is not the same, so we can't do that. We have to make this one the same as that. So we have to times the bottom here by 8, but also the top by 8. And this will give us 1 over 24, negative 40 over 24. And now since the denominators are the same, we can add the tops, and this brings us to y equals negative 39 over, and the same bottom, 24. So that's my y value that we got, and overall that's the solution to our problem. So our solution is 1 over 6 comma negative 39 over 24. that point on whatever the graph looks like is going to be where it crosses at 1/6 on the x and -39/24 on the y. And you put that's exactly where the two lines will cross. So that's pretty cool. So where the two lines will cross. It also means what value, what x value and y value will solve this equation will make it -1, and we'll solve this equation to make so that it's true as well. It's the only two numbers that will make it so both equations are true. All right, so that one was a really tough one. Now we have to do kind of an example of how to do a linear system when it's a word problem. And this is a really tough example because it talks about interest rate, which I'm sure a lot of you might be confused about. So it says, create a linear system to model the situation. Nuri invested $2,000, some of it at an interest rate of 8%, some of it at a better interest rate of 10%. After 1 year, the interest the person got was $190 out of that $2,000. So then they had $2,190, which is nice. In this problem here, you have to create two equations. So one, I see the number 2,000, so I'm going to say 2,000. I know that the amount of money invested at one rate plus the amount of money invested in the second rate has to be $2,000 because that's how much the person invested was 2,000. So the amount invested in one of them, the 8% one, and the one invested in the second one, the 10% one, when they add together they should be $2,000. So that's one equation that I can come up with. So I'll denote x is money in rate 1, the 8% one, and y is money in rate 2, the 10% one. So now I have one equation. We know we have to create another equation here. We're saying the interest must be $190. And what is interest? It's your amount of money invested times the percentage, okay? So it's kind of interest rate from rate 1, which is the amount of money you invested at rate 1 times 8%. Okay? And how did I get 0.08? You take your percent and you divide by 100. Okay? So whenever you're using percentages, you always generally take the number and divide by 100. You don't actually use the number itself in math. So now we go plus the rate that you have the second rate, the amount of money you invested in that. The interest that you'll get from that is the amount of money you invested times 10% of that. Okay? And again, 10% or 10 divided by 100 is 0.1. Okay? So this is our second equation that we came up with. The money invested is equal to, the money you earned is equal to the amount you earned at the first rate and the amount you earned at the second rate. The amount of money you invested is equal to the amount of money you invested in the first rate and the amount of money you invested in the second rate. Okay, this is a very hard thing to do and to get used to. Just need lots of practice to bring it from these word problems to those equations. Alright, so now that you have two equations, we can solve for how much money exactly did Nuri put in rate 1 and rate 2. Because we could guess, we could say maybe he put $100 and $1,900 there, but I'm sure if you plugged it into this equation, it would not work out. It would not equal $190 made. So let's solve this problem. If I look at it, which one's the easiest equation to use? Probably 1. So I'm going to solve for either x or y. Okay. So I'm going to solve for y. So our 1 is 2,000 equals x plus y. So if I want y by itself, I got to subtract the x to the other side. So it's going to be y equals 2,000 minus x. Okay. So now I solved for one variable. Now what do we do? Well, since I have y from equation 1, I have to plug it into 2. Okay, our 2 is 190 equals x times 0.08 plus y times 0.10. So y is 2,000 minus x, so instead of y, we have to put 2,000 minus x. So this is x times 0.08, and this we have to put 2,000 minus x times 0.10. So now we have just x variables, so we can solve for x. We just have to do a bit of algebra. So it's 190 equals, I'm going to switch it around, 0.08x. And then we have to do some distribution, 2,000 times that, negative x times that. So it's going to be 2,000 times 0.1 gives us 200. And negative x times 0.1 is negative 0.10x. And so now we can combine both this number and that number together. 0.08 plus negative 0.10x is equal to negative 0.02x, and then we still have that 200. We have to subtract that 200 to the other side, so we'll get negative 10 equals negative 0.02x, and then we have to divide by negative 0.02 onto both sides, and we'll get an x value of, I might have to use my calculator here, negative 10 divided by negative 0.02 is going to give me $500. So we can see that 500 out of the $2,000 was invested at rate 1, because that's what x is, 8%. Okay, so that's our x value, and if we want to find out what the y value is, we have to plug that back into either this equation or that one. This one's the easier one, so I'm going to do that. Plug into 1, and we're going to get x plus y equals 2,000. Our x is 500, so I can write that in. And then we got to solve for y, so let's minus that 500 onto both sides, and then our y is going to be $1,500. Okay, so this tells us definitively that $500 was invested in rate 1, $1,500 was invested in rate 2, so that Nuri got $190 in interest and overall invested $2,000. So in the notes package, I also have these next two questions, which are just other examples of substitution. I won't do in this video, but I have the answer keys written, and it'll be posted up under files. Thank you.